Good morning, one and all. Good morning, students. Today we discuss about 15th chapter, that is semiconductor or semiconductor devices. Okay, why are using semiconductor in the nowadays? Going to semiconductor in the before 1948. There is some transistors are there. They having vacuum tubes. Vacuum tube means it having some electrodes, 2 electrodes, 3 electrodes, 4 electrodes, 5 electrodes, like this. Suppose it having 2 electrodes, that is a diode. There is 3 electrodes like this, that is a triode. 4 electrodes, it is called triode. 5 electrodes is called pentode. It having triode, tetrode, pentode. They having vacuum tubes in 1940. Before 1940 having 1948 above. Below 1948, some of the devices, electrical devices having vacuum tubes, like transistors having vacuum tubes. Some vacuum tubes are 2 electrodes, 3 electrodes, 4 electrodes, 5 electrodes. That is depends upon the resolution. Okay, this can be having some disadvantages compared to semiconductors. Okay, before last 50 years, the solid state semiconductors are formed. After 1930, the solid state semiconductors electronics are came, that is a semiconductor devices. Why are you using semiconductors? Modify the vacuum tubes. Vacuum tubes having some low long life, that is a disadvantages, some failures of the vacuum tubes. Why are you prepare the semiconductors? That is the disadvantages of the vacuum tubes. They having low long life, that is a long life. After some time, 1 year, 2 years, they can be damaged. And also low reliability, configuration is very low. There is very big size, like this. They having big size, it can be not removable to other places. It is a very big size, that is a vacuum tubes. Other name of vacuum tubes is called valves. In old TVs and computer lab is there is a valves. This type of valves is called vacuum tubes. In before 1940, there is a triode, tetrode, electrodes is there. There is a vacuum tubes in televisions or computers. Old computers is there, in which we want they are having vacuum tubes. From vacuum tubes, it can be modified the semiconductor after 1930. That is a semiconductors, solid semiconductors can be modified. It come to the semiconductors. Okay, what is the future of semiconductor? It is having high long life compared to vacuum tubes. They having low long life. It is having high long life and high reliability. Its configuration is high. It is having very resolution, like small size. The vacuum tubes are big size. Semiconductors devices are small size. They can be used in the LED, like remote, television, solar cell, okay, etc. Nowadays they can be cell phones easily. It is a very small size, memory, storage, energy purpose, and also easily prepare. If you want to prepare within 1 week or 2 weeks, it can be vacuum tubes can be prepared 6 months, 1 year, like this. It is can be preparation is long time. And also low power loss or low power consume here for semiconductor. In the case of vacuum tubes, high power consumption, there is a high power loss, because and also here we can apply the low voltage. We can apply the 2 volts, 3 volts. We get semiconductors can be transmit the electron flow. They get current. In the case of vacuum tubes, we can apply we can heat the temperature. up to so high temperature, that is 6600 700 kelvins. Here only 2 3 4 5 6 kelvins we can apply the semiconductors, we get the current. In the case of vacuum tubes, we get we can apply the high temperature. It is we want to, there is a high power consumption, or we can apply the high voltage. We the vacuum tubes are operating at high voltage, semiconductors are operating at low voltage. That is the future of the semiconductor compared to vacuum tubes. That is the semiconductors are used in the applications like cathode ray tubes, LED, LCD, okay, like this. First since LED, in the case of LCD to LED, and cathode tube rays, and solar cell, okay, solar cell, and radio detector of the radio waves, and mobiles can be and also they can be used in the field effect that means field effect transistor, BJT, bipolar junction transistor, BJT. It is a FET, field effect transistor, BJT, bipolar junction transistor. They can be used in the applications of the semiconductor, and also etc. They having more research on going on semiconductors. The semiconductors are having large number of applications, not like this laser, LED, solar cell, and PET, jet, more only this is in the textbook. Nowadays research also going on semiconductor like this, and also we can using Chandrayaan 1, Chandrayaan 2, that means BARC, DRDO. They also using semiconductor devices, small chips. It having high storage applications, okay, nanoparticles like this. Semiconductors are using nano particle applications. Nowadays they are using semiconductor material. The semiconductor materials are, example is silicon and germanium are the best example in the for semiconductor material. Okay, going to this class. Okay, semiconductors having Ohm's law. The semiconductor materials having Ohm's law. Ohm's law is equal to P is equal to IR. That is voltage is increases, current is increases, like this. Voltage on x-axis, current on y-axis, like this. They can exhibit the Ohm's law. And also main advantages of the semiconductor is compared to conductor, insulator. Okay, according to classification of band theory or classification of materials can be classified into three types. One is conductor, the second one is semiconductor, third one is insulator. Okay, we are going to semiconductors. Semiconductors are the most applications compared to conductor, insulators. Okay, for example, semiconductors materials are the motion of the charge controlled. The charge carriers can be controlled the semiconductor material. That means we can apply the electron that can be controlled. The motion of the charge carriers can be controlled in the semiconductor. Okay, we cannot control in the conductor, in the semiconductor. That is, and also they obey the Ohm's law compared to like this, Ohm's law. And also motion of charge carriers control. Charge carriers can be controlled in the semiconductor devices. Okay, it is can be that is memory purpose. The example is the motion of the charge carriers. Okay, now we going to classification of solids. conductor, semiconductor, insulator. Okay, now we are talking about one is conductor, second one is semiconductor, third one is insulator. Okay, in the case of conductor, more number of free electrons is there. Okay, now what is the conductor, what is the according to band theory we can explain, but in the conductor the free electrons is more, they exhibit the high electricity. They exhibit the high electricity. Free electrons is more, they get high electricity, high conductivity. That is, high conductivity is there, low resistance. Low resistance is there, the current is more in the case of conductors. In the case of semiconductors, okay, going to insulator, there is no free electrons. This type of metals, there is no free electrons, and also electricity also not going to this type of metals. Example is that is wood, paper, pencil, pen. Okay, what is the example of conductor? Copper, iron, zinc, etc. This having number of free electrons. Okay, now we discuss this metals, but here is some resistivity and okay, they having free electrons and resistivity, conductivity in between insulator and conductor. Suppose in the case of conductors, the resistivity is range of resistivity rho is equal to 10 to the power of minus 2 to 10 to the power of minus 8 ohm meter. The units of conductivity is called 1 by resistivity. Okay, resistivity range of resistivity for conductor, that is 10 to the power of minus 2 to 10 to minus 8 ohm meter, and also conductivity 1 by rho, that is sigma is equal to 1 by rho. Rho is sigma is equal to 10 to the power of 2 to 10 to the power of 8 Siemens meter inverse. It is high conductivity. Okay, 10 to the power of 2 to 100 to 10 to the power of 8 Siemens meters inverse. Okay, this is the high conducting materials. The conductors having high conducting materials. Going to semiconductors, the rho is same. This electricity and resistivity, conductivity, current is the thermal and electrical properties of conductor. Insulators, the semiconductors having in between them, they having in between the conductors or insulators, they having some properties: electrical, thermal, resistivity, conductivity, current, voltage, resistance, any extra they having in between conductors and insulators, that is medium properties. Suppose resistivity 10 to the power of minus 6 to 10 to the power of 6 ohm meter, and also conductivity is 10 to the power of 5 to 10 to the power of minus 6 low Siemens meter inverse. It is a low conductivity, small. It is a small conductivity. And also in the case of insulator, the resistivity is rho is equal to 10 to the power of 11 high, 10 to the power of plus 19 ohm meter to 10 to the power of 11 to 10 to the power of 19. Okay, in the case of conductivity is low, it is 10 to the power of minus 11 to 10 to the power of minus 19 Siemens meter inverse. It is the conductivity in the insulator. This is a conductivity and resistivity in the case of semiconductor. The conductivity, resistivity in the case of conductor. Okay, in what is the difference in between the conductor, semiconductor, insulator? Okay, according to band theory of solids, the metals can be classified into three types, that is conductors, semiconductors, insulators. What is the band gap? Any metals having two bands. Any material having two bands. One is the upper level, that is the conduction band. Upper level is conduction band. The lower level is valency band. That is valency band. The top of the valency band to bottom of the conduction band is the energy gap of given material. The energy gap of another name of energy gap is called forbidden gap. Forbidden gap is also called energy gap. Energy gap or forbidden gap, whatever may be. Okay, EG is called forbidden gap. Okay, how much energy gap in the case of conductor, how much energy gap in the case of semiconductor, how much energy gap in the case of insulator. The basis of the energy band gap. Okay, now we discuss about the according to the band gap. Okay, this is the energy gap is more in the case of insulator. This is in the case of insulator. Okay, in the case of semiconductor, the small energy gap. It is semiconductor. Okay, in the case of conductor, there is a conduction band, there is a valency band. It is a conduction band, it is a valency band. Okay, there is a electrons are there in the valency band at 0 Kelvin temperature. Okay, now we discuss what is the conduction band, what is the valency band. We can derive. Okay, in the case of conductors, the energy gap is almost 0. In the case of conductor, the energy gap is 0. That means flow of electrons is increases. The electrons is more. There is no band gap. The electrons and holes are combined. That is number of holes, number of electrons and holes are there. They exhibit the high electricity, high conductivity. For example, is copper, iron. The energy gap is 0. That means conduction band and valence band can be overlap in the case of conductor. That is a reason in the okay, now we discuss what is the resistivity, conductivity, what is the electrical properties of the conductor, this is the reason. The high conductivity, number of free electrons is more, the electricity is more, conductivity is more, resistance is less, because the conduction band and valence band will be together, they will be combined to each other. That is the main reason of the this is the reason. Okay, going to semiconductor. In the case of valency band, some of the we are talking this for conductors, semiconductor, insulator at 0 Kelvin temperature. At 0 Kelvin temperature, some of the electrons are jumped to conduction band. Sorry here this is the valence band, this is the conduction band. Some of the electrons are jump to the very large small gap. The small gap means it is a positive charge. The electrons are can be jump to valence band to conduction band. There will be small current. This type of metals can be exhibit the small current or small electron flow, partial flow of electrons. That metal, some of the elements are exhibit the small current, or it small current, small element is there, or some metals having partial flow of electrons. This type of elements is called semiconductors, or small current to exhibit the metals is called semiconductors. That means and also the some metals having thermal electrical properties in between conductors and insulators. This is also called the semiconductors. That is definition of semiconductors can be explained different uh, 3 or 4 number of times. Okay, this is the definition of the semiconductors. That is semiconductors, the energy gap is approximately 2 to 3 electron volts. In the case of conductors, the energy gap is 0.1 to 0.6, like this, 0.06, 0.01 to 0.6. Compared to this is very small. Energy gap is 0.01 to 0.06. Okay. In the case of semiconductors, the energy gap is 0.2 to 3 electron volts. That is the energy gap range in the semiconductors. In the case of insulators, the energy gap is more than 3 electron volts. That is 6, 7, 8 electron volts. There is no free electrons. That is the band gap is very high. There is no transition occur in between the two bands. There is no flow of, there is no free electrons, but because they do not give any current. The example is wood, paper, pencil. That means insulator materials cannot be exhibit the conductivity at a low temperature. Okay, now we discuss about semiconductors. Is enough. What is the conductor? What is the semiconductor? What is the insulator? Is over. Now we discuss about the semiconductors. The semiconductors can be very different types. That is the elemental semiconductors and compound semiconductors. Semiconductors are are elemental semiconductors or compound semiconductors. Okay, that is compound semiconductors can be inorganic semiconductors like cadmium, that is CDS, and gallium arsenic, etc. This is the compound semiconductors. Elemental semiconductors are silicon and germanium. Okay, this is a semiconductor. We talk about semiconductor. Semiconductors can be two types. That is elemental semiconductor, compound semiconductor. Compound semiconductors is nothing but inorganic, organic. Inorganic metals are gallium arsenic phosphate. Organic metals are anthracene and polyethylene, etc. Okay, this is the inorganic, organic compounds. This is the elemental semiconductors. These semiconductor devices using organic compounds. Mainly semiconductors devices using inorganic metals for research purpose. Organic compounds are using for semi polymers, and also elementary semiconductors can be used for more for future applications. Okay, on the basis of the energy band gap, you can explain them. What is the conduction band? What is the energy band gap? Okay, in the case of, according to, suppose we talk about best example semiconductors, silicon and germanium. Germanium and silicon having what is the, suppose we take silicon atomic number. What is the atomic number of silicon? That is 14. The electron configuration of the silicon is 1s2, 2s2, 2p6, 3s2, 3p2. Here 4 6 10 plus 4, that is a total 14. Remains these are the free electrons like this. Okay, I want to only this is last table. This is a 2 and also this is a 2, so like this, like 1 2. This it is the 3s orbital, it is the 3p orbital. Remaining are full. This remaining are fulfilling only 1s2 it is fulfill, 2s2 fulfill, 2p6 is fulfill, only empty 3s2 or 3s2 and 3p2. These are 4 elements outermost orbitals can be participate in the semiconductor materials. Okay, this having any electrons, so each electrons having different energy levels in the energy diagram. Okay, this is the energy diagram like this. In the case of energy diagram, is the energy levels. Okay, according to energy levels, the energy band, this type of is called this energy levels with one band. This is this type of band is called energy band. This involves energy levels, is 1 level, 2 level, 3rd level, 4th level. Is the energy level of the material in the valence band. Okay, these energy levels in the valence band, the energy level in the valence band. Suppose we can take silicon having 8 states, 8 in states, 4 in conduction level, another 4 is in valency level. These are 4 in states. 4 in states in the valence band, 4 in states in the conduction band. This is the energy diagram for silicon. Okay, here 8 electrons, 4 n states in the conduction band, 4 n states in the valence band. What is the valence band? Means the energy band which including the energy levels is filled with electrons. That is like this. The electrons are fulfilled with electrons. That is a valence band. The empty band, it is a conduction band at 0 Kelvin temperature. This is the band above the valence band, empty band, is called conduction band at 0 Kelvin temperature. At 0 Kelvin temperature, electrons is occupied in the valence band. The conduction band is empty band at 0 Kelvin temperature. This is the example of the silicon material, a silicon atom.